Hello everyone. Today is day 27 of solving a LeetCode problem every day, and today I have solved find duplicate integer. So one thing I want to say is I already solved this problem, and honestly I didn't solve this myself. I had to look at the solution. I honestly don't really know how anybody could solve this problem without looking at the solution, honestly, but I mean it is what it is. Um, so you're given an array of integers nums containing n plus 1 integers. Each integer in nums is in the range 1n inclusive. So basically what it's saying here is that the array nums contains n plus 1 integers. However, each integer in the nums array is between 1 and n. So basically what this is telling us is that every single number in the array is a possible index in the array. It will never be out of bounds because at most it can be n minus, at most it can be, so the length is going to be n plus 1 elements, but at most it can be n. So it's not going to go out of bounds. You'll see why. You need to know that in a second. But every integer appears exactly once, except for one integer which appears 2 or more times. So basically it's saying that one number in the array has to repeat. And I mean, if you and it says only one number is going to repeat. And if you kind of just look at it for a second, so each integer in nums is going to be between 1 and n. However, there's n plus 1 integers in the array. So there has to be some number that repeats. But anyways, here in this example, we have nums 1, 2, 3, 2, 2. 2 is outputted because 2 repeats. And here the output is 4 because 4 repeats. So the question here, what really makes this question difficult is, for one, can you solve this problem without modifying the array nums and using constant extra space? So basically, that eliminates a lot of possible solutions, because one thing you can do, for example, is sort the array. So if this array was in sorted order, which I mean it is, then you can just iterate through the array and check if the previous element, or if the current element is equal to the next element. Because if there's some repetition that's happening, there's going to be 2 consecutive elements that are equal to each other. So in that case, there's a duplicate integer. The other case would be by using a set, like I've previously used in other solutions. You can just create a set and add numbers in. And if you, before adding in each number, you would just check if that number is already in the set. And if it is, there's a duplicate. So yeah, those are the 2 solutions that jumped out straight at me. The first sorting solution is going to be, I believe, n log n. Let me think about that for a second. Yeah, it should be n log n. And then for the other solution with the hash set, that should just be linear, but you're also using extra, like you're using O of n extra space. So it wouldn't really satisfy this follow-up question, which is a problem I encountered with this specific problem. But anyways, this is how you can solve this problem. So you can look at this problem as a linked list problem. It's not necessarily an array problem. And the reason why I say that is because what we're actually trying to do here is find if the linked list that we're constructing contains a cycle. And let me actually pull this up here. So for example, we have this test case 1, 2, 3, 2, and 2, which is what I wrote out here. So at index 0, it takes you to index 1. So index 1. Index 1 takes you to index 2 because there's a 2 here. So now we're at index 2 right here. Index 2 takes you to index 3. So we're at 3. And then this would be index 3 here. Then index 3 just takes you back to index 2. So here, as we can see, there's a cycle in this linked list. So what I'm basically trying to say is we can interpret each of these values in the array as an index. And by following these indexes, we can construct a linked list. And if there's a cycle in this linked list, we know that there must be a duplicate integer since we're going back to some index more than once. So that's that's kind of the base of this solution. There's an algorithm called, I think it's like Floyd's algorithm or something. Like, it's something about like a slow and fast pointer. Basically, I don't know what the algorithm is exactly called, but the general idea is you have a slow and a fast pointer. So you have a slow pointer here and a fast pointer here. They both start at the same place, but the difference is the slow pointer increments by 1 each time, while the fast pointer increments by 2 each time. So after the first iteration, the slow pointer goes from 1 to 2, but the fast pointer goes from 1 to 3. And then by the next iteration, the fast pointer goes from 3 to 3, and the slow pointer goes from 2 to 3. And as we can see, slow and fast pointer are both pointing to the same node, so they've intersected. And since they've intersected, we know that there's a cycle in the linked list, since the fast pointer has basically looped around and went back to where the slow pointer was. So essentially what I'm doing here is I'm using that algorithm. So we have a slow pointer and a fast pointer, and the fast pointer moves twice each time. So slow, we go num slow. So we start at 0, of course. So num slow takes you to 1. Takes you to index 1, which is 2. But fast goes to nums fast. So we go nums 0, which is 1, and then nums of 1, which is 2, which is basically how you're incrementing twice. It's because you increment once here, then once in the outside here again. And then eventually at some point, these pointers are going to intersect, and that's how you know that there's a cycle. And then basically the second part of the solution, let me just control Z over here. Our slow pointer and fast pointer intersected over here. So right here, both pointers intersected. And if the distance from the intersection point and the beginning of the cycle was x, and the distance from before the intersection point, so from the beginning of the linked list to the intersection point, is p, you can mathematically derive that p is always going to be equal to x. And I mean, I'm not going to really get into how you can do that here, but the general idea is if you were to say that the distance in the cycle before the intersection point is c minus x, and then the distance from the intersection point to the beginning of the cycle is x, you can pretty much construct an equation based on the fact that a slow pointer is just equal to 2 times of a slow pointer is going to equal to a fast pointer. And then if you substitute in the fact that a slow pointer needs to traverse p plus c minus x times before you reach the intersection point, and the fast pointer needs to move p plus c minus x plus x plus c minus x times to reach this intersection point, you can get some cancellations here. This x will cancel right here, so you'll have something like p plus c minus x, and here you'd have 2p plus 2c minus 2x, and then this would be p plus 2c minus x. Then if you do some cancellations, so you can subtract the p here, this becomes p, and then we have a plus 2c here, and we could subtract 2c, so the c's are gone. Then we have a negative 2x, we can add an x and just end up with a minus x equals 0. So we have a p minus x is equal to 0. And then if you bring the x to the other side, we have p is equal to x. So basically that's how you can prove that the distance between the intersection point to the beginning of the cycle is always going to equal the distance from the beginning of the linked list to the beginning of the cycle. So based off that fact, what I'm doing here is I'm initializing another slow pointer that starts at the beginning of the linked list again. And then we're going to increment the slow pointer and the other slow pointer by 1 each time. Then at some point, they're both going to have to intersect. And since we know that the distance between the beginning of the linked list and from the intersection point to the beginning of the cycle are always going to be equal, once we're incrementing these 2 pointers, they're eventually going to intersect at the beginning of the cycle. And the beginning of the cycle is the element that repeats within the linked list. So that's basically what we're doing here. We're incrementing each pointer, and then once they intersect, we just return a slow pointer. So yeah, I know that's super confusing. I honestly don't even like fully understand it myself either. But I mean, once you kind of do the math over here, it makes a little more sense. But the time complexity of this is just going to be O of n, since it's going to be linear, since you're basically just going to process each element. There's no nested loops or anything, so it's going to be linear. And then space complexity, of course, is constant. But yeah, that's my solution for the day.